Hello, I'm Marco Di Serra. I'm the head of the chair of Power Electronics at University of Kiel. I want to say something about the project, the HEART project, which is an ERC consolidator grant. So it's an excellence European grant, which has been carrying out for 5 years, now it's coming to the end of the project, and now we have some interesting result to show. We will have a workshop to present this result. This project was focused on the so-called smart transformer, which is a power electronic transformer, which is intended to be a revolutionary technology for the electric grid. But the project has also been focusing on other aspects which were interesting for a smart transformer, but can be applied also in other fields. So, for example, topics as a power converter, modular power converter, which can be applied, for example, in wind energy or in storage system or in charging station. And also the topic, which is a very hot topic for power electronic, about reliability and lifetime. Because power electronics is spreading around in the electric grid is one example, but also there are a lot of appliances which use now power electronics. But then we have to count on power electronics, so power electronics should be enough reliable. So we have been focusing on how we can, through control approach, improve the lifetime of this power converter and better even control the lifetime of such power converter. So I will present, let's say, 4 main spots that can give an idea of what we have realized. This is the first one. This is the version 2 of a part of the smart transformer. It is a power converter which uses the new technology of silicon carbide, which is highly efficient, and is also a special power converter which is based on a modular topology, which uses a multi-winding transformer, and this can have application, as I say, for an electronic transformer in the electric grid, so a smart transformer, but also, for example, for a charging station. We have actually another project, there's a proof of concept project, which is a spin-off project of this one, which is aiming to bring actually this to market, either finding a company which can bring this to the market, or to actually so create our own spin-off company. As I say, reliability and lifetime is a very important topic for power electronics in general, but is a very big challenge, especially for this smart transformer, this power electronic transformer. Classical transformer has a very long lifetime, and so if you have such a new technology in the field, we have also to carry about how this technology can also longer work without problems, so have less maintenance need. So the way in which we have decided to approach this kind of problem is using active thermal control. We have invented a new technique which is called active power routing, in which basically we say, okay, we have a modular structure, and then we decide to actually load more those cells of this modular structure which they have higher lifetime respect to those that are weaker. So these kind of things we have tested in a very special setup that you can see here, which is something which can also use for other power electronic converter testing, in which we can see in real operation the temperature inside the semiconductor or inside the capacitor using some sensor, and then under realistic condition we can see how we can influence the temperature of these devices, and as a consequence their capability to withstand such a kind of stress for longer time. And we have used this kind of setup to test our ideas and to prove if they were actually working. When we started the project, we of course had the idea that the smart transformer could bring some advantages to the electric grid and allow to rethink the electric grid, reinvent the electric grid, which up to now has been always actually using a very simple device, which is the traditional transformer, which has almost 130 years of history in use. And then we needed actually a system which could allow to test the capability of this smart transformer. For this reason, we have built this part of the laboratory in which we have a computer which is able to simulate in real time part of the electric grid. Then we have a power amplifier where we can basically create a voltage which is reproducing what is in a realistic grid. And then we have several power converters which are actually emulating a smart transformer in the electric grid to see which kind of service this smart transformer can give to the grid in that specific situation. But this kind of system we have built for the project can also be used for several other purposes, just again to test power electronic converter for wind turbine, photovoltaic system, storage system, and their interaction in the electric grid. We have even tested to have high voltage DC transmission. So this is a flexible power electronic laboratory which allows us to cover all the problems and the topics that have to do with the integration of power electronics into the electric grid. We are here in the last spot that I wanted to show because it also gives a little bit a look to the future. This medium voltage laboratory is almost ready and has been funded with European infrastructural money and also with the contribution of the Kiel University and the EKSA. Is a really special laboratory which allows to test smart transformer, but also other power electronic technology up to 10 kilovolt and 1 megawatt of power. Also with the capability to be connected as we planned to the network emulator, which will allow to make this test in realistic grid condition. And this laboratory in a few days will be ready and will start to be operative. And this also brings a little bit near to the possible application of this smart transformer. From 2 years, started a project from a company, Scottish Power in Scotland, where they basically will test in the field several smart transformers and then will test the capability of this device to show to the company what this device is able to do. Of course, these, a part of our scientific outcome of this project, will be a very good argument for the company to believe in this technology. Also consider the Scottish Power is part of a large industrial group that is the group Iberdrola. We are also involved in this project and we are actually helping the company to bring this project to the success. And something else I can also say is that we plan in this corner of the laboratory to create a storage laboratory which will be done in cooperation with the colleague in the material science and will be the further step of the development of our research and application.